Hi everyone, my name is David Torres. I'm a junior studying computer science here at Rice, and this is my project for the Build.com challenge of Rice Datathon. So if you're like me, you lost a lot of money on game stuff. That's why I chose a data set on financial transactions. So I actually do research on my stocks before I buy them. As you can see in this data set, an example of an entry would be an agency purchases a certain amount from a vendor with a certain description for that purchase or transaction. So this is a transaction history database. And the objectives for the Build.com challenge are to use this history of financial transactions to answer the following questions. How can we quantify a successful business? And how can we identify similar businesses to recommend vendors to them? So what makes a successful business? Is it the ability to make large purchases, the ability to make frequent purchases? So I defined it as being able to consistently increase your spending over time. And the keyword there is consistency, as we'll see later in the presentation. So when I was looking to visualize trends, I first plotted a scatter plot of all the transaction histories that occurred for a certain department. For this example, we use the Department on Disability Services. On the left, that's the initial graph, and it looks super scattered and you can't draw any conclusions from it, which is why I decided to use a running average of transaction costs, which would, as you can see on the left, make the trends much easier to visualize. And here it's very clear that there's a downward trend, which would be indicative that something is happening with this business that you should shy away from or look to see if you can improve. So quantifying success, how can we compare businesses based on their running average of transaction costs? So my first inclination was to run a linear regression on each business and sort by the highest slope, as in which business will give me the most amount of returns over this amount of period. As you can see on the left, the slope doesn't seem like it's a very useful factor because the Office of Contracting and Procurement just happened to make a bunch of transactions in 2016, which increased their slope. However, this is not indicative of a business that is consistent and consistently increasing their spending over a period of time. On the right, however, it seemed this is the number one business when I sorted by R-squared correlation. And as you can see, this business is consistently increasing their spending over time, which implies consistent growth and a good investment. Some interesting finds that I happened upon on the left here, there's a bit of sporadic behavior. A lot of businesses and agencies were like this. One thing I didn't have time to investigate, but I would like to, if I had more time, is to look at the significant dips. For example, here in the Office of Municipal Planning, what happened in 2016 and 2017 that led to this huge downturn in spending. Additionally, what happened in 2020, the pandemic, how has it impacted businesses, and which businesses have been more successful than others in 2020 with their spending. So part two was how to quantify similar businesses. The way I went about this was I said a business was similar to another business if they frequently purchase from the same or similar vendors. But what is a good metric for defining how important a vendor is to a company? Is it total purchase amount, average purchase amount, number of purchases? I decided for this project to go with number of purchases because it makes the most sense to me. If a company purchases from a vendor once, they're more likely, and they continue purchasing, it's more likely that that vendor is important to them. So to quantify how similar another business is to another and make a recommendation, the analysis pipeline I used was to first create a vector quantifying that business's vendor interactions using transaction count. Then using that vector, I'd calculate how similar it is to other businesses by using a similarity metric between both vectors. For this example, I use cosine similarity, but there are a lot of other types of similarity that I could experiment with. Next, I would find the top 3 similar businesses, as in Are they similar using the cosine similarity? And I would analyze what types of vendors that they're using. If at least two of the three most similar businesses purchase from a certain vendor, then I would say that that is a good vendor recommendation to make to that business, and they should look to purchase from that vendor. Some things I could improve in this area. I look towards collaborative filtering and locality sensitive hashing to see if I could make better recommendations, or if I could sort businesses into different buckets to quantify them as perhaps similar to other businesses in the same bucket.